Working with electricity can be dangerous. Engineers, electricians, and other professionals work with electricity directly. Others, such as office workers and salespeople, work with electricity indirectly and may also be exposed to electrical hazards. Electrical safety is practices and procedures that minimize the risk of injuries or fatalities from electrical accidents. It involves recognizing and avoiding electrical hazards using safe equipment and adhering to established rules and regulations. OSHA's electrical standards are 29 CFR 1910 Subpart S and 1910.331 through 1910.335. These standards focus on preventing electrical hazards in the workplace by ensuring proper design, installation, and maintenance of electrical systems. OSHA also requires specific work practices, training, and the use of appropriate PPE. OSHA's electrical standards are based on the National Fire Protection Association NFPA 70E and aim to minimize risks like electrocution, electric shock, and fires. This standard focuses on the electrical safety in the workplace, addressing hazards like electrical shock, arc flash, and arc blast. It outlines safety procedures and requirements for employees working with electricity. Electrical hazards pose significant risks in various workplaces, including the potential for burns, electrocution, shock, arc flash, arc blast, fires, and explosions. These hazards can be minimized by understanding their nature and implementing appropriate safety measures. The main difference between an electric shock and an electrocution is the outcome. Electric shock is a non-fatal electrical injury, while electrocution is a fatal electrical injury. Electric shock causes injury but not death, while electrocution results in death. Electrocution is defined as death caused by the passage of electric current through the body. Electrocution is also considered one of the Focus 4 hazards. Focus 4 hazards represent the cause of nearly 60% of all construction fatalities each year. Electric shock is when electric current passes through the body, often causing a sudden involuntary muscle contraction. Burns and falls are very common with electric incidents. The severity and effects of an electric shock depend on the factors such as pathway through the body, amount of current, length of time of exposure, and whether the skin is wet or dry. Conductive materials like metals pose an electrical safety risk because they allow electricity to flow easily. Examples of good conductors include metals like copper, aluminum, and silver. Human bodies are also conductive, making them vulnerable to electric shock. Water is another very dangerous conductor. Water increases the risk of electrical accidents since water is a conductor of electricity. It's crucial never to operate electrical equipment in wet conditions. An electrical burn is tissue damage that results from electricity passing through the body, causing rapid injury. Types of burns include direct contact, like touching live wires, electrical equipment, or power lines, arc burns, and thermal burns. Arc flash and arc blast are two different but related electrical hazards that occur during an electrical fault. An arc flash is a sudden and intense release of energy, light, and heat caused by an electrical fault or short circuit. An arc blast is a powerful pressure wave generated by the explosive force of an arc flash. Arc blast temperatures can reach as high as 35,000 degrees Fahrenheit. Electrical fires occur when electricity or an arc fault ignites combustible materials. Overloading circuits, like plugging too many devices in one outlet, can cause overheating and sparks. Faulty equipment such as damaged tools or worn cords can also lead to shocks and fires. Another hazard that can occur from electricity is combustible dust. Combustible dust explosions can be ignited by electrical sources, such as sparks from machinery, faulty equipment, or static electricity. These sparks can ignite airborne dust clouds, leading to explosions and potential secondary explosions that can be far more destructive. Overhead and buried power lines carry extremely high voltage, which can result in electrocution. When working around energized lines, maintain a safe distance, wear proper personal protective equipment, and keep at least 10 feet away from overhead lines. When using a ladder near electrical lines, use a fiberglass ladder instead of metal one. Fiberglass ladders are the safest option when working near electrical equipment or lines because they are non-conductive. Maintain a 10-foot distance between the ladder and power lines, even if they seem de-energized. This table shows the safe power line clearance distances for various line voltages. Energized lines can also be located underground. OSHA requires employers to contact the state's 811 service or designated utility location service. This service will notify utility companies to mark the approximate location of underground lines in the excavation area. Damaged or exposed wires and cords pose significant safety risks, including electric shock, burns, and potential fires. Damage to cords usually occurs due to misuse and improper storage. Worn or frayed extension cords and cables must not be used, and they must be taken out of service. Flexible cords and cables must be protected from damage. Sharp corners and projections shall be avoided. Flexible cords and cables that pass through doorways or other pinch points must be protected to avoid damage. Extension cords used with portable electric tools and appliances must be of the 3-wire grounding type and designed for hard or extra hard usage. This ensures proper grounding and durability for the harsh conditions that they are likely to encounter. Extension cords are not meant for permanent wiring and must be rated for proper use. Always check the correct amperage and voltage rating for the cord and ensure its rating for the intended environment, indoor or outdoor. Extension cords are not meant for permanent wiring and must be rated for proper use. Overloading the extension cord can cause a fire or cause it to warp. Ensure all equipment and extension cords bear the mark of an independent testing laboratory such as UL, Underwriters Laboratory. Protection devices are designed to protect property and people from electrical hazards like overcurrent, short circuits, and voltage spikes. These devices include fuses, circuit breakers, surge protection devices, and ground fault circuit interrupters. These devices work by interrupting the electrical current flow when a fault is detected, preventing damage to equipment and reducing the risk of fire or electrical shock. In an electrical circuit, a fault is when the flow of electricity deviates from its intended path, often due to damage or a disruption in the circuit. Fuses break the circuit when an excessive current flows through it. Fuses are typically replaced after blowing, indicating that a fault has occurred. A circuit breaker is a safety device that automatically shuts off electrical power in a circuit when a fault or overload is detected. Surge protectors protect electrical equipment from voltage spikes and surges, mostly used to protect computers, printers, and other electronics from too much voltage. They often incorporate features like on and off switches, fuses, and arresters to help manage these surges. A ground fault occurs when there is a break in the low resistance grounding path from a tool or electrical system. The electrical current may then take an alternative path to the ground through the user, resulting in serious injuries or death. The ground fault circuit interrupter, or GFCI, is a fast-acting circuit breaker designed to shut off electric power in the event of a ground fault within as little as 1/40th of a second. Types of GFCIs are receptacle, portable, and cord connected. Grounding is a conductive connection to the earth by channeling electricity to the ground. It's a safety measure that provides a path for electrical current to flow safely into the earth in the event of a fault. The third prong on a plug, often referred to as the ground prong, is used to ground and protect workers using metal-encased tools, equipment, or appliances from electrical shock. For example, if a tool becomes energized, the equipment ground provides another path for the current to flow through the tool to the ground. Double insulated tools are identified by a square within a square symbol or the words double insulated on their label. Double insulated tools provide protection from electric shock by using a special insulating system instead of grounding. OSHA requires that electrical tools and equipment, including devices and cables, are listed or certified by a nationally recognized testing laboratory, like Underwriters Laboratories. Underwriters Laboratories is a safety organization that provides product testing, certification, and safety standards development services. They are recognized by OSHA as a nationally recognized testing laboratory. Lockout tagout are practices and procedures necessary to disable machinery or equipment, preventing the release of hazardous energy while employees perform servicing and maintenance activities. When cleaning or servicing equipment like machinery, motors, or electrical panels, lockout-tagout ensures the equipment is shut down and cannot be unexpectedly started up during maintenance. When working on electrical panels, lockout-tagout ensures the electrical supply is disconnected and cannot be inadvertently turned on while the work is in progress, resulting in electrocution. Lockout-tagout extends beyond electrical safety to protect against other forms of hazardous energy, such as mechanical, pneumatic, and hydraulic. You must be trained and understand your company's lockout-tagout procedures. Lockout-tagout typically involves padlocks, labels, and other methods to physically prevent the equipment from being turned on. Each lock should have only one key, and the key should be kept by the authorized employee who owns the lock. The locks should have a label clearly indicating the owner's name or identification. Tags provide visual warnings that equipment is under maintenance and identify the individual performing the work. The tag should be clearly visible, durable, and include specific information about the work being performed, the employee responsible, and contact information. Lockout-tagout steps are as follows. Number 1, preparation. Identify the equipment, energy sources, and procedures. Number 2, shutdown. Stop the equipment in a safe and controlled manner. Number 3, isolation. Disconnect the equipment from energy sources. Number 4, lockout-tagout. Apply lockout-tagout devices, locks and tags, to the energy isolation devices. Number 5, stored energy check. Check for and eliminate stored energy. And number 6, isolation verification. Verify that the equipment is safely isolated. OSHA requires that all electrical conductors and equipment in the workplace be approved. This means they must be accepted, certified, listed, or labeled by a nationally recognized testing laboratory. Equipment must be installed and used in accordance with any instructions included in the listing or labeling. Electrical equipment shall not be used unless these markings are legible. Employers must ensure sufficient access and working space is provided and maintained about all electrical equipment to allow for safe operation and maintenance of such equipment. This space must never be used as storage. Live parts are the conductive components of electrical equipment that carry a potential electrical shock. Live parts of electrical equipment operating at 50 volts or more must be guarded to prevent accidental contact. Guarding prevents accidental contact between a person and a live part, which could result in serious electrical shock. The employer is responsible for ensuring live parts are guarded. Live parts can be guarded by various means, including enclosures, like boxes or cabinets that prevent access to the live parts, partitions or screens that restrict access to qualified personnel only, elevated platforms or balconies that keep live parts out of reach of unqualified persons, and insulated covers or barriers that prevent accidental contact. When using power tools, inspect power tools for damage. Use power tools and equipment in accordance with the manufacturer's instructions. Never carry a tool by the cord. Never yank the cord to disconnect it. Keep cords away from heat, oil, and sharp edges. Disconnect when not in use and when changing accessories such as blades and bits. Do not use in wet, damp environments. Keep working areas well lit. Ensure that cords do not cause a tripping hazard. Remove damaged tools from use and use double insulated tools. For electrical safety, the PPE you wear depends on the job you're doing. For example, PPE worn by an electrician will be more stringent than PPE worn by somebody who may encounter the common electrical hazards. Examples of personal protective equipment may include, but is not limited to, non-conductive hard hats for both electrical shock and impacts, safety glasses to protect the eyes from sparks and debris, face shields to protect against arc flashes or arc blast, rubber lineman gloves with leather protectors protect hands from electrical shock, and shoes with non-conductive soles reduce the risk of electricity flowing through the body. In this course, we've covered the following topics: introduction, electrical hazards, protective devices, grounding and double insulation, lockout-tagout, and safe work practices. I'm Dusty with JJ Safety. Thanks for watching.